Hey guys, so this is just a re-upload of yesterday's video. I've made an update to it and removed a couple of sections where I add thermal paste to the threads of the nozzle before screwing it into the heat block. Don't do this. It could potentially off gas. And for all you guys that haven't seen the video, if you want to learn how to solve your heat creep issues once and for all, just follow along. Hey guys, so I want to make this video today to address something that I've been getting a lot of comments about. When I did my upgrade to the Noctua fans on my Ender 3 V2, I've had a lot of comments telling me, hey man, if you use the Noctua fans, you're going to get heat creep, and all of these different comments related to the inefficiencies of the Noctua fan and the susceptibility that these stock MK8 hot ends are to heat creep. So after some thinking it over and experience with the printer, I did experience heat creep using the Noctua fans, but I wasn't convinced that the cause of the heat creep was the fans. I was thinking that it had to be something else. And what finally led me to this conclusion was my upgrade on one of my Ender 3 V2s. I switched that one over to a E3D V6 hot end. And if you guys haven't checked out that video, check that one out. The process was not that difficult really to do, and the hot end has been flawless. No problems at all. It's an all metal hot end, no jams, no clogs, nothing. Thing has just been flawless. And I had a similar experience with these nozzles. They do work excellent when they work, but I was running into this heat creep issue. So upon looking at the what made that E3D V6 hot end so great, I also noticed that the kit that I bought came with this tiny little fan. I mean, it was tiny, and it didn't have much more flow than the Noctua fan. As a matter of fact, I think the flow was even less than Noctua fan. So this tiny little fan was able to sufficiently cool this all metal hot end made by E3D with no problem at all. No heat creep, no issues, nothing. Now, one thing that was different about the E3D heatsink versus the MK8 style hot end is that the sleeve that goes inside is threaded. And this MK8 hot end that comes stock with these Creality printers, it's just a sleeve that's held in by pressure with this grub screw. So upon more investigation, I started to realize that the problem is not the Noctua fans. The problem is that Creality had to overcome the inefficiency of the heat break mating with the heat sink by using a fan that had a much higher flow rate. So this was the only way that they can make their hot end dissipate that heat coming from the heat break. So how to solve the problem? Well, if you guys ever built your own PC, you'll realize that PCs rely on thermal paste to transfer the heat from the CPU to the heatsink. If it doesn't matter how big the fan you have on the heatsink is, if that thermal paste is not there, the computer will overheat and it won't boot. It'll blue screen, it'll crash, and it just won't boot. So that's the answer to this. This is what solved the problem for me with these hot ends. And let me see if I have one here handy. So here's one of the spare hot ends that I have for my Ender 3 V2. And this one, if you could see, I added the thermal paste to the heat break. So where you want to add the thermal paste is to the sleeve of the heat break, just a very thin coat. You don't want it to overwhelm the heat break, but just a nice thin coat because it fits pretty tight in the bore. And then you're gonna slide the heat break into the heat sink till it bottoms out, and then tighten the grub screw. You're also gonna add some thermal paste to the threads that screw into the heat sink from the heat block. So the stock MK8 hot ends, they come with these two screws that go through the heat block into the heat break on both sides. And a lot of people tell you remove these screws to avoid the heat creep. But if you remove these two screws, what happens is the nozzle to heat break connection could be separated, could be severed, because the block is 100% relying on the pressure between the nozzle and the heat break to keep it from rotating. But as this thing heat cycles on and off, what will happen is this thing will loosen, and when it loosens, there's nothing to keep it from backing completely out. By having these two screws on the side, you reinforce this connection. So once this is torqued down properly, and these two screws are tightened, you're not going to have any problems with this thing coming loose on its own. It won't. At least not to my experience. So add a little thermal paste to these threads here on each side, and then screw these screws through the heat block into the heat sink, and that's it. So that solves the problem of the heat creep completely. It doesn't matter whether you're using the Noctua fans, whether you're using the stocky 3D fan, or if you're using the Creality fan. The heat creep is a non-issue after doing this little mod here. You don't want to put any thermal paste on the threads that go from the heat break into the heat block, because you don't want efficient heat transfer from the heat block to the heat break, because then that'll just increase the possibility of heat creep. So we don't want efficient heat transfer from the block to the heat break, but we want very efficient dissipation of the heat from the heat break to the heat sink by adding the thermal paste up here in this sleeve. Okay, so I hope that puts this to bed. Since I've done this mod to my Ender 3 V2, one of them, I haven't had any more problems. So this machine over here to my right, that's just out of camera view, has been running 300 hours plus continuously with no problems with the heat creep. Before doing this, I was getting heat creep and jams and clogs about every 100 hours. It would start with the clicking on the extruder, and then resulting in under extrusion and then clogs. So by doing this, that eliminates the problem. Anyway, let's get back to this thing. One of the things that I've been wanting to do is upgrade the stock MK8 hot end to all metal, because the limiting factor here is the fact that you have a Bowden tube into the heat block. So now these Bowden tubes, and this one is a Capricorn, so it's a little bit more heat resistant than the stock Teflon tube that comes with these Ender 3 V2s. So this one will start to run into problems at about 250 degrees. But you can print up to 240, which I've done with no problem. And I haven't had any change in the look of the Bowden tube at all. Now you start getting over 250, and then you can potentially run into problems if you're getting into long prints. If you're doing something real short, it might hold up, but definitely over 250, you need to consider upgrading to an all-metal hot end. These things, and while I haven't had the experience of this thing off-gassing on me, a lot of the forums that I've been reading is, hey man, this fumes that this thing puts out, they're really, really toxic and not good for you. So anyway, let's get back to this. To upgrade this thing, all you would need to do is change out this heat break. Now you can go online and they have many heat breaks that you can get. This one is one that I found on Amazon. It was a 2-pack. These are titanium, and it was $14.99 before tax. So I started off with this one. So I picked this one up, 15 bucks. I thought, hey man, for 15 bucks, I essentially make myself an all metal Hotend, save myself a few dollars over purchasing a micro Swiss. It's something that would be cool to try. So let's start by taking this thing apart, and I'll show you what I ran into by trying to use this budget titanium heat break. All right, so I'm going to screw this thing out. Screw the new heat break in. If I was going to assemble this permanently, this is just a test, I would coat this with some thermal paste and then screw it into the heatsink. So let me back out this Bowden tube here. Alright, so all you got to do is reassemble your heat break. And it helps to assemble these things on a flat surface because that'll keep the thing nice and even. So all I'm going to do is hold this thing here. And you want to make sure that it's in all the way. I'm just pushing it in all the way, and then I'm just going to tighten the grub screw. And you can do a final hot tighten once you heat it all up. This is just preliminary tighten. Install your 2 screws that will help with this, reducing this chance of this block coming loose. And again, I'm going to tighten this on a flat surface to keep this from moving. And you don't want these screws crazy tight, just snug them up, and I like to snug them up a little bit at a time. Alright, next up is we're going to install the nozzle. Okay, and if it's installed properly, it should have a slight gap, which you can barely see there. There is a little gap. So that means that we're good to go. Install your Bowden tube. And now the Bowden tube stops about, let's see, let's pull it back out and see. So I'm going to measure this, grab it. So you can see the Bowden tube goes in about that much and then stops. So anyway, I picked this up, I installed it, got it all ready to go, put it on the printer, and then I tried to load my filament, and my filament would not load. So one thing that I discovered with this budget titanium heat break is that the filament, it jams. Okay, so let me take the tip off so you guys can see what I'm talking about. See how it doesn't come out? It jams. So then I tried thinking, oh, you know, maybe it's just me, some user error or something. So I took this and I cut this at an angle, gave it a little, made it kind of, tried to make it cone shaped. So I cut a couple little pieces here off of it. To try to make this like a little spearhead. Put it inside there. And guess what? Still doesn't come through. So this titanium heat break, at least this brand, and I'll put the brand back up here so you guys can see, so you guys can avoid this. This brand, Polisi 3D. is not machined properly. So if you guys pick this up, you're not going to be able to load your filament. Alright, so anyway, this one was a fail, but I learned a little bit. And then another one that I had heard mentioned in the forums was one made by Slice Engineering. Now, when I went on Slice's website, Slice Engineering website, to look at them, I was a little bit shocked at how expensive they were. So on this budget one that I picked up on Amazon, it was $14.99 for two. They're made out of a titanium alloy, but you can't load the filament. The Slice Engineering heat break is made out of two different materials, which I found pretty interesting. One of those materials is copper, and the other material is stainless steel. So I ordered one, and it came in a couple days ago. I wanted to show it to you guys. So let's get rid of this. Okay. So here is the Slice Engineering version. And again, it doesn't look much different than the other one. And this thing was expensive. I think after taxes and shipping, it was like 38 bucks. So not cheap at all. So let's look at it next to the budget one. So you can see the budget one has kind of like a step there toward the bottom. And this one looks like it was machined, has kind of like a cone shape at the bottom instead of being a step. So I think that was the reason why the filament was hanging on this one. But anyway, this one is very, very interesting. And if you look real close, you might be able to see that. Let me see if I can zoom you guys in so you can see. If you look real close, this thing right here, it's kind of hard to tell in the camera, but yeah, you can see it right there. You see how it has that chamfer on the inside, right in here. It's got that chamfer. So this little tube here is made out of stainless steel. So these are three pieces. You can see it also. See if I can change the angle so you can see it on this side too. See that little chamfer down there? Right there. So that's also another piece. So this is three separate pieces, and I can tell that it's copper because I tightened the grub screw just to check the fitment, and this is copper. So you got a copper threaded section that goes into the heat block. You have a copper sleeve, and then you have a stainless steel throat inside, and these are press fitted together. So at first glance, is this thing, was it worth 35 bucks? No, not at first glance. But then when you start to really look at this thing, you start to realize that this took a lot of effort to put together. You got three different machine parts, and then after they were machined, they were press fitted together. And anyway, so let me install it on here so you guys can see if this thing was worth the extra money. So if I was going to install this, again, I'm just doing kind of like a mock-up installation. I would put thermal paste on here. Actually, you know what? I'm going to put the thermal paste on. I'm just going to go ahead and install it because my plan was to install it on the printer. But I'm going to do the installation on the printer when my nylon filament comes in. Right now I don't need to print any nylon. I don't have any nylon to print, so I'm just gonna. So what I'm using here is some Arctic MX4 thermal compound. I'm just going to apply a little bit here. And as I screw this thing in, I'm going to try to work it around. Next thing I'm going to do is install the heat block. And what I like to do here is I'll install the tip, the nozzle. And I want to make sure that that nozzle has that gap. You see that gap there? Okay, so that's like the perfect amount of gap. But the heat brake needs to be turned. So I'm going to loosen the heat brake. I'm going to turn it along with the nozzle. And then that's how I'm gonna assemble it right there. So I'm just gonna snug this back down. Install these two screws here. On these, the same thing. I'm just gonna put a little thermal paste here on these threads. Probably what I probably could have done is just put the thermal paste on the thread before putting it in, but I don't want to get it on the heat block. All right. So just like before, I'm just gonna tighten them down a little bit at a time. And on a lot of the sites that I've seen, everybody tells you to heat up this hot end before torquing it. However, in my experience, at least with working on engines, that you don't torque engine bolts when the engine is hot. You torque the bolts when the engine is cold because hot parts expand. So I'm gonna just do the same thing here. I'm just putting it on a flat surface. And if you guys haven't already seen this neat little torque wrench that you can get from Thingiverse, a very talented guy put this thing together and it works awesome. So I'm using the 1.25 millimeter thickness fins. There's some fins in there, and there's different thicknesses that you can print them. This one is the strongest one, and it works fantastic. So I'm just gonna put this thing in here, and then I'm gonna turn it till it clicks. That's it. All right, so that one is assembled. Next thing we got to do is I'm gonna go ahead and go the extra step, and like on my other hot end videos, I show you this little spacer here that you can drop inside with a little section of Bowden tube. Now this is really meant for the Bowden tube that goes all the way down into the heater block, but I'm going to use it here too because as this Bowden tube rotates around, the little jaws of this pneumatic coupler is just going to tear it all up, and eventually it's going to get loose. And anyway, if I have to replace a section of Bowden tube, I don't want to replace such a long section, so I'd rather just cut off 1/4 of an inch and then reinsert it. That way I'm not changing out the whole Bowden tube so often. So I made this little jig. The piece that we're going to cut is about 14.4 millimeters. So I'm going to go ahead and just put my little piece of Bowden tube in there. Cut it. Just pressing it up against the end here. So that's it. I got this little piece of Bowden tube. What I'm going to do next is I'm going to insert it in the little cone. So this is a little centering cone. It centers the Bowden tube in the middle. Let me see if you guys can see through it. Might be able to maybe. So if you look down in that hole, you see how it's perfectly centered. If I didn't have this little lip on here, it wouldn't center the tube. It could be off to a side, and then you could have problems loading your filament. So I'm going to go ahead and take the pneumatic fitting off, and then drop this little cone with the section of Bowden tube down inside, just like that. Then I'm going to tighten down the pneumatic coupler. And I'm just going to hand tighten this. There's no need to get too crazy with it or anything. And now I'm going to test my filament. See, my filament goes all the way down. All right, so let's put a little piece of Bowden tube in there. Okay. Insert the Bowden filament down. Okay. And I'm going to pull it out. See how far down that filament went? So that filament went all the way down into the hot end. So in the other piece, it was not going. And look, this is the flat side. It's not even the cone side. So there was no cone or anything to this, and it went all the way down. And this is a piece that came out of the So now this filament has been through the extruder. So that's why it looks like this. It's got the little grooves cut into it, if you can see. Anyway, yeah, so check it out. So it goes right down in there, no problem. So anyway, guys, this one looks like it's going to work. Can't wait to install it next week when the filament gets here. If you guys like the content I'm putting out, subscribe to the channel. If you like this video, give me a thumbs up. Turn on your notification bell. And comment. I love reading the comments. I do my best to get back to you guys as soon as possible. Till next time, God bless.